Today we'll be going through number systems and we'll be looking at binary and decimal. So first I'll explain briefly what is binary and what is decimal, and then we'll calculate a decimal value from binary. So we convert in binary to decimal and then decimal to binary. Alright, so let me start with briefly explaining binary. So a voltage is a force that moves electrons in a wire. That is all you really need to know. Okay, we could represent this voltage using binary. So V for voltage can be represented using ones and zeros. Now, these ones and zeros are just logical values and they are not real numbers. They just represent the voltage. So you might see something like 2 to the 8 with some binary around it and thing, and they don't mean, this value doesn't mean, this value is more code than in other sense, in a sense. Okay, so we'll get into that in a moment. So when a light switch is on, yeah, when it's on, it could be represented as a 1, and when it's off, it could be represented as a 0. Okay, so it's very simple. Light switch on, 1, light switch off, 0. They don't really have anything much to do, so the total amount of values from a light switch, or from a switch, sorry, is 2. Okay, 1 and 0. Or you could say 0 and 1. Okay, binary means 2, and the two numbers you're dealing with is 0 and 1. And decimal means 10, and we're dealing with numbers 0 to 9. So we're covering all the numbers in between 0 and 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And decimal meaning, not, it don't have to be 7.03 or anything like that. We just mean anything in between 0 and 9 is our decimal value. So don't confuse it with decimal point and all that. It just means we're using a 10 um, digit numbering system, 10 numbers in the numbering system, and we're using, and for binary, it just means that we're using 2. Okay, so moving on. Find the decimal values from binary values. Okay, so in this example here, zoom in a little bit. Right, we have one light switch is on, that's this one, and one light switch is off, that's that one. Okay, the light switches are set up in a way where, because it's binary, you could have 2, and the first switch will be 2 to the 0. 2 to the 0 is equal to 1. Right, if you check your indices in maths, you know that, right? And 2 to the 1 is equal to 2. So the switches just keep going on like this, and each switch is a bit. So right now we have 2 bits. Okay, and the question asking, if the light on, if the switch on the left hand side is on and the switch on the right hand side is off, what would be the decimal value from this? Well, it's easy to calculate the binary value because we know on is 1 and off is 0. So we'll get 1 and 0. Okay, switch 1 and switch 0. You could call them, these usually have names, but let's call this switch 0 and let's call this switch 1. Right? So we could say 2 to the 0 is 1. 1 multiplied by 0. 1 by 0 is equal to 0. And 2 to the 1 is 2. 2 multiplied by 1 is 2. So 2 plus 0 is 2. So 2 is the decimal value for the binary 1, 0. Alright, so that's pretty basic. I really do think, I hope everybody could follow along with it. And just a recap of what we did is basically we stated that, just get my grab tool. A switch is on and off. It have two states. On is 1 and off is 0. Yeah, binary means 2, decimal means 10. So binary have a base 2 and decimal have a base 10. Um, if we have two switches, on and off, we could represent the on with a 1 and we could represent the off with a 0. Okay, switch 0 is the first switch, and in computers a lot of the maths is start from 0 to 9 or something. A lot of the like numbers that laid out in a row might start from 0 and go up to 9, because that is actually how the number system is work. 10 is not really is like start over at 10. That is why it have a 0 in it, and just go up to 19 and then it start over at 2. Okay, so one, so S0 and S1 will be switched to. So just keep that in mind. So the amount of combinations we could get from two switches will be 2 squared, which will be equal to 4. And I put 4 base 10 to say that this 4 is a decimal value, meaning that is the normal number in system always use. And here I have S1 and S2, but I really meant to put S0 and S1. But either way, the combinations will be 0, 0, 0, 1, 1, 0, and 1, 1. And that will be the only 4 combinations from these two switches could only give you 4 combinations. That is really what it's saying. So it don't really matter where you label it. It's just 2 switches and we could only get 4 combinations from it. So for 3 switches, it'll be 2 to the 3, which will give us 8 combinations. Switch 0, switch 1, switch 2. Okay. The decimal value for 000 is 0. Then we have 001, that'll be 1. 010, that'll be 2. 111, 3. 1004, 1015, 1106, 1117. So this would be the 8 combinations, right? Because we start from 0 and we end at 7. So 2 cubed is 8. So don't confuse it. And this is how we end up with um, all the binary combinations for 3 switches. Okay, I told you before that switches are bit, and I'm sure you all heard about 8 bits. So the 8 bit will work like this: 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. And I'll go on like that. And if we calculate, alright, and I didn't draw over the switches, but I keep the values here. So what will 1 mean? If all of these are 1, that means all these switches are on. So we want to calculate the decimal value for 8 bits. Okay, and all the switches are on. So we know all the switches are on, so we put 1s for all of them. And then we just square and use indices basically. So 2 7 times, 2 by 2 by 2 7 times is basically 128. 2 to the 6 will be 64, 2 to the 5 will be 32, 2 to the 4 will be 16, 2 cubed will be 8, 2 squared will be 4, and 2 to the 1 will be 2, and 2 to the 0 will be 1. Okay, if we add up all these terms, and remember, it'll be 128 multiplied by 1, which will give us 128. So when we add them up, we'll get 255 as the decimal value, because that's what the question asks, right? And this is 8-bit because we have 8 switches. And 2 to the 8 will give us 256 combinations. So the combinations will always be one more than the decimal value if all the switches were on. So that's just a kind of good note there to take. So our next example will be the same 8-bit configuration, but some of the switches are off. So the second switch, the third switch, the fifth switch, and the sixth switch, and the seventh switch will be off. So we have a 0 to represent that, another 0 to represent all the off switches. And now we know that if we was to say 2 to the 6 is 64, 64 by 0 would be 0. We could just leave out all the zeros and just basically cancel them off and only focus on the ones. So you'll get 128 plus 2 to the 5, which will be 32, plus 2 to the 3, which will be 8, plus 2 to the 0, which will be 1. And it will give us 169 as the decimal value for the binary number. Okay, so just to go over quickly what we did. First, we figured out what is binary, what is decimal, how to use binary to represent logical values, ones and zeros. Okay, how to calculate the amount of combinations you could get from different amount of switches. So 2 switches, 4 combinations, just 2 to the 2, and you go on like that. We did an 8-bit setup with 8 switches, each switch being 1 bit, and we basically had calculated the binary, which we learned just now. Okay, on is 1, off is 0, and we did the maths. So simple as 2 to the 7, 128, 128 by 1, 128, right? Example here, 2 to the 7, 128, 128 by 1, 128, 2 to the 6, 64, 64 by 0 is 0. So simple maths, you just figuring out the indices to the power 6 or whatever, and you just multiplying it by the binary number underneath, right? And then you added them all up. Very straightforward stuff, okay? We said that to find the amount of combinations, you just put 2 to the amount of switches, and to find the decimal value, well, we just did that there, okay? So let's move on to binary, from decimal to binary. And I mean, this is more the popular topic, but I save it for last because I really think you should learn all that first. And then you can get to this part. So the number 26 to binary. Now this is the easiest method you could use to basically convert to binary. I've seen a lot of videos on people doing it a different way where they were using addition. And I don't recommend that way. I think this way is the by far easiest, most straightforward way to do it. So to convert to binary, all you have to do is divide by 2 and state the remainder. Okay, this is the remainder here. So 2 into 26 will give us 13. Okay, and the remainder will be 0. So that's straightforward. 2 into 6, 3. 2 into 2, 1. So 2 into 13 will give us 6. remainder 1. Alright? 2 into 6 will be 3. So 2 into 6 will be 3. You're writing it down here. Remainder 0. And 2 into 3 will be 1. Remainder 1. 2 into 1 will be 1, will be 0. Remainder 1. So that's all you do. If you have the number 13, all you have to do is say, okay, if I was to take 1 away from 13 to make it an even number, that'll be 12. So all I have to do is say 12 divided by 2 is equal to 6, right? But it's really 13, and this 1 could go as the remainder. So it's just a kind of way to show how we doing it here, because I mean, if you really, you could get like 6.5 on on your calculator now. But that's not the way you're dividing it here. So you could just, like what I say, you could round it off to the lower even number. If it's an odd number, you find, so like what I say, 13, you find you find 2 into 12, and now 1 for the 13 that remain, you just put it there. Alright, and the next thing about it too is when you're writing it over, you're writing from in this order, from the bottom go up. Alright, so it'll be 1 1 0 1 0. Just don't make that mistake, because if you write from the top, it'll mess it up now. And so let's do our next example, 51. Okay, so 2 into 51 will be 25, remainder 1. So 2 into 25 will be 12, remainder 1. 2 into 6 will be 3, remainder 0. And 2 into 3 will be 1, remainder 1. 2 into 1 will be 0, remainder 1. So we'll have it from, again, from the bottom up, 1 1 0 0 1 1. Okay, and what I want to show you here is that we can still look at the other values. Even though this is the answer, the real number is really what I've written here, with these 4 here and these 4 here, and they're separated for a reason. So it's really 0 0 1 1 0 0 1 1, and not 1 1 0 0 1 1. Right? These are kind of just filling in the blanks with these zeros here, and this will represent positive 51. But what if we wanted to do negative 51? Alright? Well, I did an example with negative 10 here. So let's go and do negative 10. Negative 10, it will be a couple more steps. But first we take the negative 10 and we basically we basically convert it to positive 10. Okay? And we find the binary like normal. So 2 into 10, 5, remainder 0. 2 into 5, 2, remainder 1. 2 into 2, 1, remainder 0. And 2 into 1, 0, remainder 1. Okay, and we write it from, come up, and we'll get 10, 1 0. So 1 0, 1 0. So 10. Okay, so we know it's supposed to have 8 digits, right? Because we're dealing with 8 bits. And what we do to calculate the negative is basically inverting these 8 digits. So what was a 0 is now a 1, and what was a 1 is now a 0. So 0 0 0 is now 1 1 1, and 10 10 1 0 1 0 is now 0 1 0 1. Just the opposite. And then we add 1 to it. Okay, so 1 plus 1, but we're doing binary addition here. So you have to be careful. So 1 plus 1 is So in binary, 1 plus 1 is equal to 1, 0. It's not 10, it's 1, 0. Because it's only 2 digits, so it already move 1. So 1 on 1 is 0. This 2 here is just base 2. Don't already take it on. That's just to show you that there's a binary number. Um, so this 1, 1, 1, 0, the 1 will come across. 1 and 0 is 1. 1 and here's just zeros. Okay, another 1 here. So everything will just come down. So it'll be 1 plus 0 is 1, 0, 0 plus 0 is 1. 1 plus, so it'll be 1 plus 0 is 1, 0 plus 0 is 0. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1. And the answer will be 1, 1, 1, 1, 0, 1, 1, 0 to the base 2. And this will basically mean negative 10. So how the computer recognize negative numbers is basically by ones being in front here. As you can see, is the inversion of the actual value, the actual binary value for 10. And yeah, that's how the computer is really check these values. So I mean this was really a recap of the last lecture I did, and I'm trying to post a couple videos a week, at least one for each lecture as my personal notes from it. And I mean this information could be very useful, like, and understanding these like base concepts like logic and binary. You could really do a lot with it, as you will see during the next couple of weeks and doing that. I mean, this is basically the fundamentals, everything that you may need to know. Yeah, so we found out why we use logic, how to represent logic with zeros and ones, how to calculate decimal values from binary, how to calculate, how to convert decimal values to binary, and what is 8-bit. We learn about the switches, and we learn about how the computer is recognize negative decimal numbers and represent it in binary. So if you guys found this information to be useful, please leave a like, subscribe. It'll help me out a lot. So thanks.